I'm Tim Carroll. I lead Microsoft's efforts to support the global research community. What is HPC? HPC is high performance computing. But if we go back 100 years ago, computers were actually people. The early physicists realized that if they could put more computers or people onto a single problem, they could get the answers faster. Fast forward to where we are today, and if one computer can solve a problem, 5,000 computers can solve it even faster. That is HPC. I've been doing this for almost 20 years now, and what has been the most satisfying about all of this, about working in high-performance computing, is that it supports high-performance research. And so we have the great opportunity and benefit of seeing direct outcomes from the work that we do in supporting the researchers in their effort to make other people's lives better. But when people hear high-performance computing, it sounds they immediately gravitate toward, oh, that means supercomputers. High-performance computing is really much more simple than that. It's actually a capability, not a thing. And let me put it in terms that potentially humanize it. So that if we think about what high-performance computing is, a good example of it is forecasting the weather, right? There are two elements of forecasting the weather. There's getting the forecast right, writing the piece of software that takes all of the inputs and comes out with a forecast that's accurate enough so that we can make plans based off of that forecast. But there's another element of it. We need to be able to run that model and get the results back in time frames that are meaningful. Meaning we want to get 100% accurate forecast, but if it takes 5 days, that doesn't help us tomorrow. So the optimal situation is to get 100% accurate forecast, but that we get it by tonight so that we can make plans for tomorrow. So frequently, when people hear high-performance computing, they immediately visualize huge rooms of blinking lights and smoked glass and cables everywhere. In actuality, the compute function that we provide in high-performance computing is pretty simple. Right? Virtualization is where I take a single computer, use a piece of software to make it look like 5 different computers so that multiple people can use it and make more efficient use of that system. Think of HPC as the inverse of that. What we're actually doing is taking 5 or 15 or 50 or 5,000 computers, using a piece of software that enables us to pool that compute resource together so that we could tackle problems that people could barely imagine 50 years ago, 100 years ago, 5 years ago. I often use weather and weather codes as an example of not only capability, but how HPC is used, because weather is one of the most taxing models and workflows that people can run. There are a large number of inputs and it's very computationally intense. And so it's a good indicator of what's possible on a system if you can run a weather code efficiently. There is an open source weather model called WRF. And that's used by a community of about 40,000 people worldwide who not only use it but contribute back to the code. Recently, we ran a benchmark where we were able to scale, meaning we were able to run WRF over 100,000 cores simultaneously. Now, there are very few centers worldwide with an on-premises supercomputer with the ability to allocate 100,000 cores to WRF. But what's significant about what we did was not that we were able to run this very large workflow compared to how someone would do it on-prem. What was very important is that what we did could be replicated if someone wanted to by any of the 40,000 users across the WRF community. Microsoft is delivering the infrastructure and tools to the global research community to uncap their creativity and their capability. Those who previously didn't have access to HPC resources now have it. And those who were fortunate enough to have been using HPC to solve their problems can now expand their horizons even more broadly. Our team supports the global research community, but more importantly, we're part of it. Because we know that by enabling even one more scientist with one more great idea, that ultimately it helps us all.